Write down the domain, which would actually be a sort of challenging college algebra problem for beginners. It's 0 to 1/2, and we have to stop at 1/2 because if we pick a number larger than 1/2, the term on the right there would have a negative radicand. Okay, and that's closed brackets because the square root of 0 is equal to 0. That's defined. That's okay. All right. Now, that's not really that important here because we can just use the Cauchy Schwarz inequality. And I have it written kind of, I won't say backwards, but we're going to write it in the other order down here. Now, so here we go. And I'll go ahead and label it. Right here, you can see, at least utilizing the notation that we have up there, your a sub 1 would actually be this 1 that you see right here. And then the function, the square root of x, would be your b sub 1. Okay. Now, practice competitors here don't have to write all this down. You know, they just can see it. But I'm not one of those guys. Now, and this would be your a sub 2, b sub 2, right here. Yeah, this problem is interesting to me because it was on a well-known math channel, and you were supposed to do it without calculus, so they did it with trigonometry. So my instructions are no calculus, no trigonometry here. Now, if you take a look here, it's just an immediate application in reverse. Notice the sense of the inequality up here is from right to left. I just wrote it from left to right here. Okay, and everything's in place. Everything's in place here. Now, so what we're going to get right here is that this would be equal to equal to 17. 4 squared plus 1 squared is 17. So we have 17 right here. Okay. Now, y'all, if you notice right here, everything cancels out. And you would have the square root of x squared is x. And right here, you would have minus x. And so what you end up with is just 17 times 1/2. Okay, like that. But notice that the left-hand side is squared. And so if we remove the square roots, we get what we're seeking here. We get the square root of x. This is just the original problem. Again, y'all, I'm just taking the square root of this object, we're writing down the argument. The squaring and square rooting are inverse operations. And so this would be less than or equal to, and it's going to, this is for all x. So we'll go ahead and write the square root of 17. The square root of 17 over 2. Okay, folks, and that's exactly what we set out to prove. This establishes that this expression, which is the original problem, is less than or equal to the square root of 17 over 2. Now, something that's kind of interesting here as far as the domain goes, notice that if you substitute 0 in right here, if you substitute 0 here and 0 here, you just get, let me just write this down, where x equals 0 is just the endpoint of the domain, right? So if you substitute x equals 0 right here, you just get this part is certainly 0, and then right here you would get 4. You would get 4 square root of 1/2, right? But notice to bring the 4 inside the radical, you would have to square it. And so this would be the square root of 16 over 2. So you can see the maximum does not happen at the end point. It happens a little bit to the right, which we could solve for that, I suppose. Okay, so that's notice that this number is certainly less than this number. So the max happens a little to the right of 0 somewhere. And I'm not solving for that. I don't even know if I could do that, actually. But in any event, I hope you enjoyed the video.